Okay.
Yeah. So I think we had the most questions on the last few here. Although we also had some questions on like how to read the graph. So maybe we'll go back to the graph and start here and figure out how to read it, and
Yeah.
then do some of the questions. All right. So at first it kind of looks like a bunch of lines on a grid, right?
Mm-hmm.
And there's a few keys here, a few clues, and a whole bunch of information. So on across the bottom, you've got different temperatures. So it's like as you're heating something up, the temperature increases. And along the side on the y-axis, those are all how much. So how many grams? How much of that thing can you dissolve? And in the middle is all the different salts. So every line is a different salt. And some of what you have to do is figure out from the name to the formula, like which salt, which of these curves you care about. Because for any single question, you only care about one curve.
Yeah.
Anything on a line is saturated. That's just the fancy term for, like, that's the most you could possibly dissolve at that temperature. That's what we'll call saturated.
Mm-hmm.
Any point under a line, so if we're looking at this line here, any point under that line we'll call unsaturated. So like unsaturated is under, on the line is saturated, anything above the line is super saturated. Does that make a little bit more sense of the graph? Okay. And then we had some questions down here.
My question was on the second, third line. How much more would you have to add to each solution?
Love it. Yeah, let's go with it.
Like that second one in the little box area. Yeah.
Like that second one. So there we've got.
It says 40 G of whatever that formula is and 100 grams of water at 40 Celsius.
Yeah. Okay. And in some ways, it's just a whole bunch of numbers here, right? So, like,
Yeah.
what are the numbers? What do they mean? Where do they go? Okay. So let's start by figuring out which curve we care about. And which salt do we like are we looking at in this question?
Whatever. I don't know which one that is.
Great. Whatever that is.
Yeah, whatever that is.
KNO3. Do you see a
It doesn't
KNO?
fall on the line.
Yeah, do you see a KNO3 in that graph?
Yeah, but it doesn't fall on the line under 40. Oh, now I get, wait. Oh, I think I get it now.
So
Maybe.
you found the KNO3. And so the KNO3 curve is that entire curve. Like that whole curve describes KNO3.
Mm-hmm.
Okay, so we found our curve. We want the KNO3. And let's do the temperature next.
Just 4.
Exactly. So we'll find the temperature side. There's the temperature side. Find a temperature of 40.
Mm-hmm.
And follow, so you're going to take that temperature of 40, follow it up to your KNO3, and you're looking for exactly that point where those two lines like meet, where they cross. Exactly how much KNO3 can you dissolve at 40 degrees as your temperature. So you find that point, and then for the last step here, you take that point over to the Y, over to the side, and you're looking for how many grams of KNO3 can you dissolve.
So 60.
60 is fine. 62 is fine. 64 is fine. Is
that the answer, or do you have to take things away, like subtract?
Good question. Yeah, and we'll figure out that part. Are you seeing how we kind of found? If you want, you can use a straight edge, like a ruler or a piece of paper or something like that. Like you can kind of line it up with that little point, and then take that line over to the side, and read like that point over on the y-axis. Does that part make some sense?
Mm-hmm.
And do ask if you've got more questions along the way. Okay.
I just have the one question on the 2 on the bottom.
Gotcha. Alright. So we figured out when it's saturated, we took that line over to the side. When it's saturated, we can dissolve 60, 62, 64, kind of whatever you read is just fine. The graph is kind of blurry. So you can dissolve 62 grams of KNO3 at 40 degrees Celsius. And you're right, Kat, because the question is asking how much more would you need to add to create a saturated solution?
Mm-hmm.
So you've already got 40 grams. It's like you want it in your little beaker, you want a full 62 grams. That's how much you want, but you already have 40. There's already 40 grams in there. So it says how much more do you need to dissolve to get all the way up to get 62? So how would we figure that out?
Subtract it.
There you go. And what would you subtract from what?
62 minus 40?
There you go. Yeah.
What would be... It's a weird number. 22.
Yeah. You can always use a calculator too. That's what you're looking for. So you start with some amount. There you started with 40. You said how much more do you need to add to get all the way up to saturated? So we found that point where it is saturated using your graph. Take your temperature, go up to your curve, find the amount. That's how much you have when you're saturated. That's how much you want. If you already have some, the question becomes, we have this much, we want this much, how much more do we have to add? that's how much you have to add. So add 22 grams to make a saturated solution.
That makes sense.
Awesome. Are there other questions in this realm? Do you want to try some on the bottom, like those last three?
Oh yeah, those last three confused me. Kind of did.
The last three, would the cerium sulfate be the K2Cr2O7?
Oh, good question. Yeah. The very last one asks you for cerium sulfate. And we haven't, those are like weird words. Cerium is Ce. Sulfate is SO4. Cerium is apparently a +3. Yeah. +3, sulfate's -2. That is your cerium sulfate.
Okay. That last one isn't going to be very big.
I agree. Yeah, you're saying that last one's not going to be very big.
Is it just 9 grams?
Yeah.
Well, okay, then I got it now.
Do you want to explain how you got that?
I connected the dots and I was like, oh, okay.
Nice. Do you want to explain how you got that one?
Okay. So basically what I did is I went to the 50 Celsius and I started from there. And then I found what I'm going up to. So I found that weird thing and I see that that's like a 3. Is approximately a 3. So I did 3 times because there are 300.
Oh.
Yeah, and that's what you do with the upper one is that you go up to that, and whatever grams you get that it can reach with that, you just do it 2 times. You just add them together.
Exactly.
Oh, okay, that makes sense.
Yeah, it just clicks sometimes.
Perfect. Yeah, instead of just 100 grams of water, now you have 300 grams of water. So it's kind of like having 3 100-gram cups. And in each one...
I am going to hop off. Thank you so much for all the help.
Absolutely. Thank you.
Bye.
See you tomorrow.
My only other question was, it says which compound is least soluble at 30 degrees Celsius and then which is most soluble?
Right. That is another popular question.
And you said least is like the bottom of the curve, so you look at the bottom of the curve. I think is what you said.
Exactly.
The top is the most soluble.
Yes. Because like the bottom is like the least amount of stuff, like a smaller numbers are at the bottom and the bigger amounts are at the top. Yeah.
There's no one line that goes near 30. The closest one to 30 is there's 2 of them that are close. The closest one is the NaCl or whatever that is.
Oh, sure, yeah. And it's, which compound is least soluble at 30? What's the unit on that 30?
Oh, that makes sense.
Is that a temperature or an amount?
There's so many lines and numbers, I don't know anymore.
Right? No, that's fair. Yeah. Yeah, that is one of the tricky things about this, is that there are a lot of lines and numbers, like you're saying. But we can get it. Don't worry, we got this. So here's your 30. And what's the unit on that 30?
Celsius. So temperature.
Got it. That's a temperature. We just matched that unit. We've got degrees Celsius. That's a temperature. Okay.
Mm-hmm.
And what was it? It was how many degrees Celsius?
30.
Okay. So find your 30 degrees Celsius. And which salt can dissolve the smallest amount at 30 degrees Celsius?
The one that falls right on it is the KCIO3, maybe?
KCl3 is really small, like it's just right there. Is there anything even small, like even less than the KCl3?
That very bottom line, maybe?
That very bottom line. That's a curve too. That's a salt.
Let's see. It's a lot. That's a big formula right there.
It is a big formula. Yeah. Yeah. But you're right, that's the curve you're looking for. It's the smallest amount that you could dissolve at that temperature. And find the name of that curve, kind of the salt somewhere on it. That is the salt that you can dissolve the least of at 30 degrees Celsius.
And what does it mean the most then? Like,
great. Yeah, what is the most soluble at 30 degrees? Okay. How could we figure that out?
just going, I don't know. This is the thing. This is the only thing that confused me about this.
Yeah.
I was like, I don't know which is least and most.
Yeah, so if least is like closest to 0, closest to the bottom, most would be
way up top, which would be that, I think the sodium something.
There you go.
Maybe?
Yeah.
Oh. Because
Yep.
I'm looking at, okay, that makes sense.
Yep, got it.
I don't think I have any more questions for you. I think I'm good.
Awesome. I'm glad you asked.
Yeah, I didn't know, and I was like, I don't know anymore. I'm just gonna ask Miss Clarby so I don't get this wrong. I don't think I have any other questions.
Cool. Good. I'm glad that you know what you know and what you have questions on. That's a good, solid skill.
All right, thank you, Miss Clarby. Have a good day.
Thank you. You too. Bye-bye.
Bye. Enjoy the weather. I have my windows open. Like, it's nice.
Yes. Totally.
My mom's like, why is it so cold in your room? And I'm like, because it feels nice. I don't want to physically be outside, but I can, like, have my blanket around me and I have the cold air coming in and I'm good to go. I'm equally balanced out temperature-wise.
Perfect.
All right.